Hello everyone, this is Sandeep Kumar from Sri Venkateshwara College of Engineering. I am giving the presentation on Z transform. These are the topics are covered under my presentation are bilateral Z transform, unilateral Z transform and inverse Z transform and the reason of convergence and the properties of Z transform. And I am going to explain the bilateral Z transform. The bilateral or two-sided Z transform of discrete time signal x of n is the formal power series x of z defined as x of z is equals to Z transform of x of n is equal to the summation from minus infinity to the plus infinity of x of n z power minus n. Here n is an integer and z is the complex number, and z is can be also defined as a into e power j theta is equals to a into cos theta plus j sin theta. And a is the magnitude of a z, and j is the imaginary unit, and the phi is a complex argument in radians. Next, I am going to explain the unilateral z transform. Alternatively, in case where x of n is defined only for n is greater than or equal to 0, the single-sided or unilateral z transform is defined as x of z is equals to z transform of x of n is equals to summation from n is equals to 0 to infinity of x of n into z power minus n. In signal processing, the definition can be used to evaluate z transform of unit impulse response of discrete time causal system. An important example of unilateral z transform is probability generating function, where n is component x of n is the probability that can be discrete random variable takes the value n, and the function x of z is usually written as x of s in terms of s is equals to z power minus 1. The property of z transform as used interruption in context of probability theory. We are discussing about z transform to find out the x of z by using x of n. Now we are going to explain about inverse Z transform to find out the x of n by using the x of z by applying the inverse Z transform. And to find out the x of n, this is the formula for find out the x of n is 1 by 2 pi j integration of x of z into z power n minus 1 with respect to z, where c is the clockwise clock closed path and circling the origin, the entirely the region of convergence in case where the ROC is casual. This means the path C must encircle all the poles of x of z. A special case of counter integral occurs when C is unit circle. The counter can be used when the ROC includes the unit circle, which is always guaranteed when x of z is stable. That is when all the poles are inside the unit circle with the counter. The inverse Z transform simplifies to inverse discrete time Fourier transform or Fourier series the period values of Z transform around the unit circle. This is the formula for x of n is equals to 1 by 2 pi. The integral limits from minus infinity to plus infinity x of e power j omega into e power j omega n with respect to omega. The Z transform with the finite range of n and a finite number of uniformly spaced z values can be computed efficiently via Bluestein's FFT algorithm. The discrete time Fourier transform, not to be confused with the discrete Fourier transform, is a special case of such a Z transform obtained by restricting Z to lie on unit circle. Here I am going to explain the region of convergence. The region of convergence is the interesting topic because it can be play with the circle unit circle like this. the unit circle when the poles and zeros are forms with respect to the problems or numericals are to be decides where the ROC is lies inside the circle or outside the circle. It is the formula to find out the ROC is a summation from n is equals to minus infinity to plus infinity x of n z power minus n, and it is the first numerical or example for the no ROC. No ROC means the limits are defined as infinity. There is no poles, so that no poles, no zeros, so that it cannot be formed. There is no ROC, and let x of n is to be 0.5 whole power n, and expand this 0.5 to the with respect to the formula from the limits minus infinity to the plus infinity. I am going to explain the I expand the 0.5 from in minus infinity to plus infinity. I am going to take on the values from minus 2 to plus 2. Here the values are summed, and there is big value, infinity values are obtained. Therefore, there are no values of z satisfies the condition, and the I am going to explain the example 2 is forms the ROC. It can be forms the ROC outside the circle, and these are the ROC. Let take the example x of n is equals to 0.5 whole power n u of n. Expanding the x of n in the intervals of minus infinity to plus infinity, it become 0, 0, 1, 0.5, 0.5 whole power. Here the zeros are obtained with the negative part because of u of n. U of n is the condition n is equals to 1 when the n is greater than or equal to 0, n is equals to 0 when n is less than 0. So the negative values are 0 and the positive values are 0.5 with respect to n value, power of n value, and it satisfies the condition is the value is less than infinity, and finally we got this output. The ROC is less than 1, so the z is greater than 0.5, so the ROC is lies outside the 0.5 unit lies outside the unit circle. And I am going to explain the anti-casual ROC. Anti-casual ROC means the ROC is lies in the center of the circle. It is the example to casual anti-casual ROC. Is equal x of n is equal to 0.5 power n u n minus minus n minus 1. U of n means n is greater than n is equals to 1 when n is greater than 0. Here u of minus n minus n minus 1. It means n is equals to 1 when n is less than or equal to minus 1. So the all the values from origin to positive values are become 0, and the negative values from the minus 1 are taken the values of 0.5 power n. And here it is satisfy the condition is less than summation of all the values is less than infinity, and using the infinity geometric series against the equality only holds if 0.5 minus 1z is less than 1, which can be written in terms of z as mod z is less than 0.5. So the ROC is lies between the circle. It is the condition. It shows the ROC is near to the center, and it can be defined as the ROC is lies inside the circle. And these are the some properties of Z transform are notation, linearity, time expansion, decimation, and time delay, first differentiation forward, time reversal, scale in Z domain, complex conjugation, real part, imaginary part, differentiation, convolution, cross correction, accumulation, multiplication, time advance, first differentiation backward. These are some properties of Z transform or the formulas are time domain with to Z domain. Some of the these are the formulas I am going to explain. I am going to explain some formulas. The linearity formula is taken as a1 x1 x of n x1 of n plus a2 x2 of n is to be defined in the Z transform a1 x1 of z plus a2 x2 of z, and time reversal x of minus 1 is equals to x of z power minus 1. These are the properties are to be from time domain to the z domain. Here the initial value theorem. If x of n is casual, then x of 0 is equals to limit z tells to infinity x of z. And the final value theorem, if the poles of z minus 1 x of z are inside the unit circle, then x of infinity is equals to limit tells z 1 to 1 z minus 1 x of z. These are the common transform pairs are u of n when u of n is equals to 1, n is greater than 0, and 0 n is less than 0, and dou of n is 1 is equals to 1 when n is equals to 0. When 0 is 0, n not equals to 0. And these are the some formulas are for signal and to the Z transform, and also for the ROC. When dou of n is equals to 1, all the ROC is all the Z's, and u of n, it is the formula for Z transform 1 by 1 minus Z power minus 1, and the ROC is lies outside the circle, and n square un is the formula Z power minus 1 into 1 plus Z power minus 1 divided by 1 minus Z power minus 1 whole power 2, and the ROC is lies outside the circle, and the another one formula minus a power n u of minus n minus 1 is equals to 1 divided by 1 minus a z power 1, and the ROC is lies inside the circle. These are the formulas for the Z transform and the ROCs. Thank you for watching.